Hello, and welcome to today's Rackspace webinar, Unraveling Infrastructure Complexities with Bare Metal. Thank you all for joining us today. My name is Jason Barnhill, and I'm a product marketer with our OpenStack public cloud. I'm joined today by Thomas Duesing, product manager for Rackspace's OnMetal Cloud Servers and our resident expert in Bare Metal Cloud.
Hi there.
Today, I'll kick off our discussion by talking about traditional options for IT hosting, both virtualized cloud environments and more traditional dedicated hosting, as well as the features, benefits, and trade-offs involved in selecting each option. Then I'll talk about Bare Metal Cloud, what it is, what it means, what it does, and how it can help you and your business. Thomas will walk you through our approach to Bare Metal Cloud using OnMetal Cloud Servers as an example. Everything from the hardware choices we've made to the implementation of OpenStack software that makes it all work. He'll show you why this matters to you and how Rackspace customers use OnMetal to power their most demanding workloads. Finally, we'll save time at the end for Q&A. Please use the chat function in the bottom left corner of your webinar window to ask questions throughout the presentation, and we'll answer them at the end. All right, let's get started. So, as many of you know, over the last 10 or more years, the multi-tenant cloud has grown quickly from infancy to increasingly widespread adoption across the IT industry. And it's easy to see why. Multi-tenant cloud environments offer a number of benefits to users. First, they're highly scalable and easy to get started. Most multi-tenant clouds have self-service dashboards and control panels, allowing the users to create and customize their own servers on demand whenever they need them. No more need to have an IT guy build it for you. You are in total control. Second, they offer cost advantages. First and foremost, you only pay for the time you actually have servers online. So you create a server, run your workload, and when you're done, you kill the server. End of job, end of server, end of paying for that server. It is true consumption-based pricing that leaves you in control of your costs. And more broadly, by leveraging cloud computing, you are using a provider's hardware in their data center, not yours. This is important because you have suddenly freed up cash that was previously tied up in capital expenditures, money that can now be invested back into the business to help you grow your business. That's great. So now let's take a similar look at a more traditional model of dedicated hosting. While dedicated hosting technology is older than cloud computing, it's still a very popular choice for businesses and organizations interested in outsourcing their IT infrastructure. Dedicated hosting environments offer businesses a number of benefits as well. First, speed and power of bare metal. Your applications and workloads run directly on the server, so there's no hypervisor or other virtualization complexity to slow down your workloads. You get consistent performance. In a dedicated hosting environment, your servers are dedicated to you and only you. This means that you know all the workloads running on that server, and you're not competing for resources with other tenants or noisy neighbors. This means no unexpected blips in performance that could impact you or your customers. Next, being a single tenant also means you have greater control and access to the servers. While this varies by provider, you would expect to be able to have greater levels of customization and ability to access the server. Greater control and access means less abstraction, which means less complex engineering work to get your workloads to perform properly. Last, but certainly not least, dedicated hosting typically offers a fixed, predictable cost structure. You'll enter into a contract where your costs are often fixed. Less volatility in your IT costs means more predictable costs and expenses for your business, which allows you to plan and forecast better. So, with dedicated hosting, you can see that you get a different set of benefits when compared with the cloud computing model we just reviewed. And it's important to fit the right workload to the right solution. But how do you choose? Choosing one forces you into trade-offs right from the start. You like the elasticity of the multi-tenant cloud, but you know it's difficult to scale. On the other hand, with dedicated hosting, you can get simpler scaling, but you give up elasticity and agility. What if we didn't have to choose? What if we could have our elastic cloud with a solution that's easy and simple to scale? What if we could harness the power and consistency of a dedicated solution with the scalability and elasticity of the cloud? After all, you want to have your cake and eat it too, right? Well, we at Rackspace aren't the only ones who want our cake. Out in the market, we see interest in bare metal growing exponentially. Let's use the OpenStack community to illustrate our point. According to the April 2016 OpenStack user survey released just last month, over 550 of the more than 1,100 users surveyed were interested in learning more about bare metal. That's over half the respondents. What's most striking is that just 6 months ago, in the October survey, interest in bare metal was so slight that it fell into the other category, representing just 4% of respondents' interests. And it's not just users taking notice. We see interest rising from industry experts such as Carl Brooks from 451 Research, who writes, "Bare metal cloud, physical hardware fully automated into IaaS, is an important and necessary direction for the overall infrastructure market to go." We at Rackspace have been working on solving this challenge to make bare metal better. I'll ask Thomas to join us now to walk you through our answer to the interest and demand shown by users and industry experts, OnMetal Cloud Servers.
Thank you, Jason. And I'm going to dive into some of the technical details behind OnMetal, starting with the hardware that delivers the performance of OnMetal, and then take a step back to look at the OpenStack-based software orchestration layers that allow the servers to be provisioned in just a number of minutes. Starting with the hardware, we use an entirely Open Compute-based fleet for OnMetal. The Open Compute project is interesting, and it's really a core tenet to not only OnMetal, but how we think as a company here at Rackspace. Just a quick background on Open Compute as a project. It was founded by Facebook in 2011, along with Rackspace, Intel, Goldman Sachs, and some others, to focus on data center optimization and efficiency improvements, but it's since expanded to focus on storage, networking, server racks, power distribution, really a pretty soup to nuts approach to data center hardware. In OnMetal V1, we built on top of Intel's Ivy Bridge platform in the Open Compute world what they call the Winterfell board design, partnering with Quanta as a manufacturing, as our primary manufacturing partner. For OnMetal V2, we've updated and refreshed not just the software, but also the hardware underneath the platform, built on top of Intel's Haswell platform, as well as part of, I should say, the Leopard board design in the Open Compute world. Open Compute has allowed us to customize and improve the efficiency of OnMetal significantly compared to our baseline hardware. So what does it look like? I find that it's helpful to get a picture of these servers in order to see really what the cloud is shaped like. So what you see here are 3 production racks of Open Compute-based OnMetal servers. These are actually in our Dallas-Fort Worth data center. The picture on the left shows the front of the rack, and the picture on the right shows the back. Obviously, these racks aren't plugged in yet. This is right after they were delivered. So you can see the giant power cable hanging to the right of that middle rack. But really what's interesting here is not necessarily that this is atoms and not bits, but really the important part here is the density optimization that we're able to gain from the Open Compute-based servers, as well as the operational flexibility that they allow us. So you see the bank of fans on the right picture This is a change that we've made as Rackspace to improve the field serviceability of the initial Open Compute design, a contribution we've made back to the Open Compute community. It allows us to increase the reliability of our OnMetal servers by removing the components or increasing the number of components that can be maintained while a server is still online. In addition to the fans, which tend to have a fairly low failure rate, we've also made the power highly available and sort of in an N-1 availability pattern. You can see the power distribution bars in the picture on the left in the center of the cabinet design. What that allows us to do is not only increase efficiency of power transfer, taking direct current directly to the servers, but it also allows us resiliency at the power supply level, in addition to the two dual source sort of A-B power configuration we have running throughout our Rackspace data centers. This resiliency extends to the network level. All servers are cabled with two 10 gigabit Ethernet links, which are configured by default in an HA bond, which I'll show you in a little more detail later on, as well as the boot devices in the OnMetal servers, which are configured in a RAID mirror to provide for redundancy and resiliency from drive failure. So when you start to look at the individual configurations of OnMetal servers, you can see that we've designed our OnMetal lineup to meet the application needs of real-world use cases. And there's a little bit of a journey to explain here as we've moved from OnMetal v1 to OnMetal v2. With OnMetal v1, we intentionally targeted a very specific type of large-scale web-facing internet application. Think sort of social or something that may be a Series B Y Combinator funded next big thing. Obviously, that takes advantage of the ability for OnMetal to scale rapidly, but it does, in hardware design terms, preclude some other use cases that we hadn't considered. And so what we've done with OnMetal v2 is we've rounded the corners a little bit, made things a little less weird, and introduced the general purpose lineup, which increases the amount of local storage, increases the resiliency of the storage, and increases the number of RAM and CPU allocation options in the lineup. Across the board, of course, you'll see 10 gigabit redundant 10 gigabit Ethernet links, as well as all of the other hardware resiliency options I mentioned earlier. Also, to talk a little bit about a performance gain that we've been able to take advantage of, going from OnMetal version 1 to OnMetal version 2, specifically with the I/O flavor. We've seen, while you'd still see the same storage size in the PCI flash going from the V1 to V2, we've seen at least a 10% read performance advantage in V2 and greater than a 50% write performance optimization when you're looking at 4K I/O operations per second, which is our standard benchmark for that matter. We've been able to make an even more substantial gain in the boot devices, moving from version 1 to version 2, seeing a 40% read improvement and a 250% write performance improvement on that same 4K IOPS benchmark. So stepping back from the hardware and talking a little bit about the orchestration systems and the software that makes OnMetal not only performant and reliable, but also fast and flexible, I want to talk a little bit about OpenStack. As you know, Rackspace is a leader in the OpenStack field. We were, in fact, a founder of OpenStack in cooperation with NASA back in 2010. At the time, OpenStack was nothing but an object storage service and the virtual machine-based compute service, Swift and Nova. Now there are 6 core services and 13 additional services and a whole slew of ancillary projects and support initiatives and infrastructure. It's a really impressive to watch. It's been, for me, really impressive to watch the OpenStack community grow. From an OnMetal perspective, specifically, OnMetal is based on the OpenStack Ironic project, and it's behind the OpenStack Compute API, which is the same API as our virtual cloud servers product that we've been proudly offering since 2012. And so what does that look like? Well, when you put it to a picture, this is a flow diagram of the systems that make OnMetal happen. So really, there's a lot of detail here, but when you're looking at the broad strokes, really the interesting thing here is at the top of the picture you see the Nova API. It's the OpenStack Compute API I mentioned earlier. The same entry point as our virtual cloud servers, so that translates really to familiarity and ease of use. So when you look at command line tools, when you look at orchestration tools like Ansible or Chef or Puppet, they work out of the box because they're familiar with the API. It's the same programmatical interface that you're used to and that your systems are used to. All of the magic we take care of behind the scenes. You see the Nova API automatically delegates to the OnMetal compute cells, and then Ironic is what drives the actual bare metal provisioning and interfaces with our networking systems as well as with our open compute servers directly. And all of these communications happen in about 5 minutes. We're seeing servers being built anywhere between 3 and 6 minutes, averaging right at 5, which we're really proud of. Another sort of behind-the-scenes thing that I wanted to touch on in more detail is the life cycle of an OnMetal server. So there's some interesting security touch points here that we've spent a lot of time honing and sort of battening down. So the diagram you see here is the life cycle of an OnMetal server. It's provisioned by an end user, and then when it's deleted, it goes into a state that we refer to as cleaning. In its cleaning phase, this is where we ensure that the hardware is clean of any data that may have been written to the machine. We also ensure that all of the firmwares on the machine are up to date and free of persistent threats, which is an increasing trend that we've been keeping an eye on very closely as an engineering team. We also verify that the hardware is working in present state. And what this really translates to is when you reprovision an OnMetal server, it's a brand new experience, so you really don't have any sense that it may have had multiple users in the past. And you have a full assurance that none of the data that you store on an OnMetal server is available to customers on down the line. So, of course, all this sounds a little science project-y, really, getting into some of the technical details, but how does it actually perform out in the field? So we've worked with a third-party benchmarking firm to measure how, in a typical relational database workload, compare the performance of an OnMetal IO version 2 server to a virtual machine offering at another provider, specifically focusing on input-output performance. So what we found was that OnMetal outperformed the virtual solution by up to 50%. And not only that, kept the performance advantage as the number of virtual users in the test scaled up, which is exactly what you see in the graph here. And so what that signals is not only is OnMetal solution that behaves like the cloud from an API perspective, but it outperforms it significantly, allowing all of the benefits of the hardware to shine through to the end user. Of course, all that's great, but how much does it cost? And this is where the story gets really interesting. When you look at that exact configuration that Prowess tested it compared against our OnMetal IO, the cost was 26% less. And of course, not only does this translate to the individual unit cost of a server being 26% less, But when you're able to get twice the performance of a VM out of a single bare metal server, you're able to consolidate your infrastructure by up to 50%. So not only is each individual server costing you less, and not only is each I/O action costing you less, but your overall infrastructure is able to be consolidated significantly. And the compounded effects of this are actually interesting as well. So when you look at not just the infrastructure cost, but the operational cost of running that infrastructure, think about the overhead that's reduced when the number of servers that you're running drop by a factor of 2. Think of the troubleshooting that you won't have to do. Think of the other items that that your operations team will be able to focus on. And this is exactly what we found our customers telling us about they've experienced in OnMetal themselves. So how does it apply to them and to their business? Brigade is a fantastic example. They were a really early user of OnMetal. Brigade they're a social media or a civic engagement platform. So they're gearing up actually for the big election season here coming up in the fall in the U.S. In addition to running causes.com, they run their full web and mobile stacks on OnMetal. And this has allowed them to gain the efficiency as well as the scalability that they need to meet their user base with a minimum amount of complexity, really. And it's quite elegant the way they built out their systems. Very full stack, though. We also look at some customers in the gaming space who have very high performance demands. As you may imagine, very seriously low latency requirements. Agora Games uses OnMetal to scale up to support the social features for some of the biggest blockbuster games out there, taking advantage of not only the compute performance but also the network performance, which is a common theme we see also with Somo Audience, which is an OnMetal customer that handles hundreds of thousands of quotes per second in a real-time ad bidding marketplace. We like Somo because they stress test our systems, but they like us because we're able to deliver economics that allow them to directly impact their bottom line. In other words, the more quotes per second they can handle, the higher their monthly revenue. And we're happy to be a part of that. So I'm going to go ahead and do a quick demo, quick tour of our control panel, as well as a walk through a real live OnMetal server. Let me get that going. All right. So what you'll see here is our Rackspace Cloud Control Panel, which you may be familiar with. We have a nice new homepage design. As you can see, there's not a whole lot going on my personal account, but really, I just want to take a quick second to highlight some of the features that we've built into the control panel. Heads-up visibility for support tickets, really fantastic and tight integration with our monitoring package, and as well as our analytics, monitoring analytics data. But what's really interesting right now, of course, is creating a server. So you see when I click the Create Server button, I'm just popped right here in the OnMetal page. We're sitting right next to our virtual servers. So one of the things, again, we like to talk about OnMetal servers is that they look, feel, and smell a lot like our virtual servers, if you could smell a server. And that includes a regional availability. You can see that build a OnMetal version 1 or version 2 server in Northern Virginia. I'm going to go ahead and build in Dallas for today's demo. So let's go ahead and pick an Ubuntu LTS release with our general purpose medium server. One additional security measure I should mention that we've made with OnMetal when you compare against our virtual servers, we do require SSH keys instead of password-based SSH authentication. This increases the default authentication posture for OnMetal servers. So I'm going to go ahead and select my default public key and hit create. And so as I mentioned before, this process takes about 5 minutes to complete, so I'm going to sort of take a slide out of Ron Popeil's playbook and log into a server that I already have created, which you can see is running CentOS 7. So first, let's just put some artificial load on the system, so it's actually doing something interesting. So we can see the load that stress test is generating and how it's being distributed throughout the system. This is also kind of a neat graphical demonstration of all of the CPU cores that are available on the system. You can see this is an OnMetal IO version 2 server that has 2 10-core clocks, which translates to 40 threads in an Intel hyper-threaded fashion. With the load climbing, but the system, of course, maintaining its responsiveness. So let's go ahead and kind of just walk through some of the other technical details while I'm logged into the system. You can see, you can see that, again, I mentioned the 40 CPU cores with the latest generation Haswell processors, sort of speeds and feeds there. Memory, with the load test steadily consuming up to the 128 gigs of RAM available in the box. Of course, one of the interesting things about the IO server is the available 1.6 terabyte PCI Express flash devices, which right now are unformatted since this is a new server. Another thing to call out here that you may have picked up on already is the mirrored RAID pair of disks that the server boots off of for storage resiliency. Just real quick, let me show you the network configuration. This just gives you a quick visual on the highly available BOM that we have by default configured in our OnMetal server's networking configurations. And all of the gory details there. So by now, logging in again. Server is still building, so I'll go ahead and we can check in on that in a little bit later. But back to the presentation. So, I mean, I really hope what you're taking away from this is that you can have the best of both worlds with OnMetal. Bare metal cloud server and cloud servers combining the benefits of dedicated solutions with flexibility of cloud to deliver not only raw power but consistent performance in an API provisioned instant deployment scenario with pay-as-you-go utility-based billing flexibility. So now I want to go ahead and bring back Jason to help us with the Q&A portion of this presentation. So I see we've got some questions in chat, so we'll kick that off here.
Great, thanks, Thomas. Great overview of OnMetal and all the features and benefits. And as you mentioned, we've got some questions rolling in. So let's start with the first one from Ian, who asked about availability of Microsoft Windows Server images for OnMetal. Can you give us an update on that, Thomas?
Yeah, it's a great question. I mean, it's absolutely something that we are working hard on here in engineering at Rackspace, and something that we are aiming to deliver this summer. We found that it's a workload and a use case for OnMetal that we want to make widely available, and so we want to make sure that we do it right. And this is, of course, would be in addition to all of the Linux options that you saw available on the control panel, Ubuntu, CentOS, Fedora, and then we'll also be delivering Red Hat Enterprise Linux this summer.
Great. Thanks, Thomas. And as a reminder, if you'd like to get in a question, please utilize the chat function, which is built into the lower left corner of your screen. Next question is from Chris. He writes, the bonded and tagged interfaces, are they configured via Nova or are they built into the image?
Yes, that's a great question, Chris. So the configuration is initially written into the server on the config drive, so it comes out of actually Neutron, and then it's written into a JSON file that's stored on the config drive, which is just a small portion of the OnMetal boot devices that we carve out for a little bit of configuration help. And then once the server is provisioned, a little post-boot program called CloudInit, which you may be familiar with in the OpenStack world, reads the JSON files in the config drive and then configures the interfaces based on the JSON spec in the config drive.
Great. And Chris has a quick follow-up question. So it uses OSNet config.
That's a good question. I'm not entirely sure if we use OSNet config or not. I'll have to get back with you after I follow up with our engineering team.
Great. Thanks for the questions, Chris and Ian. We've got a couple more rolling in. Okay. All right, here's a softball for you, Thomas. Where is OnMetal available?
Yes. So we launched OnMetal version 1 in IAD, and it is still available in our Northern Virginia region today. We've expanded the availability with OnMetal v2. It's currently available in not only Northern Virginia, but as well as Dallas-Fort Worth and our London region, servicing the EMA market.
Great. Thanks, Thomas. Next, will OnMetal work with my dedicated environment?
Yeah, so another great feature that we've added in OnMetal version 2 is the capability to connect to isolated and secure cloud networks. What that gets you, in addition to the ability to create secure networks in the OnMetal or virtual cloud servers environment, is the ability to connect to a Rackspace dedicated environment over Rack Connect version 3. Rack Connect version 3 essentially just extends that isolated cloud network to a VLAN network segment in your dedicated space, very seamlessly, logically expanding the network for your OnMetal cloud servers, as well as the capabilities that you're able to add to your environment.
Great. Thank you, Thomas. Next question. What level of service or support is available to these OnMetal servers?
Yeah, it's a good one. So at Rackspace, we obviously pride ourselves on the fanatical support that we deliver to our customers through our technology solutions. OnMetal is no exception to that. We offer OnMetal as a managed infrastructure offering, but probably more interestingly as part of our managed operations package. And so what that means is that we pair a world-class technical wrapper with this world-class technology that I've been talking about to help you tackle your business problems, your technical problems side by side.
Great. Thank you, Thomas. Last call for any additional questions from the audience today. Just going to double check to make sure I've caught them all so far. Okay, well that looks like we got a question coming in here. Give it a minute. All right. Tony asks, are there bare metal load balancers? What can you tell us about that, Thomas?
Yeah. So that hits on a couple of interesting points. The answer is Rackspace does offer bare metal load balancers. We offer both Brocade and F5 load balancers. In an OnMetal configuration, those would be connected to your environment via a Rack Connect 3 link. So the load balancers look a little bit more like a dedicated device, but from an OnMetal server perspective, they would still be part of the same network segment. And of course, that's in addition to the cloud load balancing offering that we offer in a virtualized fashion, or anything. What we have found is customers who have success installing an open source load balancer like HA Proxy on an OnMetal server to sort of create your own really more flexible and more scalable bare metal load balancer offering.
Great. Thanks, Thomas. Next question is about the Open Compute project. Thomas, do you see Rackspace taking advantage of Open Compute project configurations more broadly beyond OnMetal?
Yeah, absolutely. We've already expanded our use of Open Compute-based servers into our virtual cloud servers platform. We're also expanding the use into our cloud block storage servers. And what this really allows us to deliver is servers that are customized directly to the needs of Rackspace and its customers, and allows us to increase our efficiency in a way that we can pass on to our customers.
Great. Thank you. Let's see. Another question coming in. So Thomas, would OnMetal support container-based applications?
Yeah, definitely.
How would that work?
Bare metal is really the ideal platform for container-based solutions, either Docker, or we've seen systemd inspawn and CoreOS, Kubernetes, those sort of larger orchestration systems that you kind of have an interesting relationship with their host servers, in that they allow you to significantly increase the usage. Increase the load on the server safely while still managing all of the processes more easily. So of course, those are solutions that we've seen customers sort of try out on their own. The most success we've had here at Rackspace is obviously with our Carina offering, which is a bare metal container offering that allows for really drop-dead simple provisioning and scaling of a Docker-based container environment.
Great. Thanks, Thomas. Question from Tony. How would bare metal servers, like OnMetal, connect to a Rackspace shared SON service?
Yeah, and that's sometimes connecting back to the dedicated storage environments can get a little bit tricky. It really boils down to some specifics around the configuration. There are some there are a couple of different ways you could approach this, and generally that question is best worked through, I think, with a technical account team. So Tony, if you're a Rackspace customer, feel free to reach out to me through your account manager, and we can really figure out how that works specifically with your environment.
All right. Thanks for your questions, Tony, and thanks for the responses, Thomas. Let's see if we've got any other questions coming through the chat. Quick reminder to just enter any questions you've got into the chat window down there so we can see them and hopefully address them for you. Yeah, I think we've got one coming in here. Okay, so Thomas, this one is about OpenStack, and are there any projects or coming capabilities through OpenStack that you think may benefit OnMetal Cloud Servers or bare metal in general?
Yeah, definitely. We remain very active and committed to the OpenStack community, not just with Ironic, but the project as a whole. And there are absolutely features and performance and efficiency improvements to be had in the Ironic project. I think, though, one thing that I want to highlight in the OpenStack world that's sort of coming to a bare metal service near you possibly in OnMetal forms or possibly in Carina is the OpenStack Magnum project, which is really interesting when you start to look at combining the operational efficiencies that container orchestration platforms like Docker Swarm or like Kubernetes or like Mesosphere's Marathon platform allow you to take advantage of, but they tend to be very complex systems to set up. And so that's directly the problem that OpenStack Magnum is looking to tackle in the configuration, in automated configuration and setup of these kind of systems. And we compare perfectly with a service like OnMetal, where you would then have not only the ease of deployment, but also total control of your environment in a highly performant bare metal environment.
Great. Thank you, Thomas. Okay. That's all the questions we've got today. So I want to thank you all for joining and participating. If you'd like to reach out to us, my contact information is jason.barnhill@rackspace.com. Spelling and everything of my name is on one of the first slides there. And I'd like to thank Thomas for joining us today and sharing with us his expertise and passion for the bare metal cloud. So thank you, Thomas.
Thank you, Dave.
Okay. Well, thank you all very much for participating, and enjoy the rest of your day.
Take care.